Hello, good evening. Welcome to Real Learning Center. We are continuing our classical or PUC classes, and today actually I am going to do some numericals on the electrostatics. So, electrostatics we have already started and completed first two chapters in a few videos. Now, today we are going to do some numericals. So, I have seen that many of the students find that doing the numericals in physics a bit harder. So, I'm not going to do hard numericals. I am going to do simple ones. So you get some confidence on how to do this. And important point here to understand is please look at what is the process, how do we do the numerics, how to remember what are the kind of formulas that we use, how to picturize the problem. These are all the things that we have to learn. And I am going to basically do very simple ones which are there in your textbook. I'm going to use the textbook. This is basically NCERT textbook or PUC textbook, any textbook that you have in that first chapter, starting from the first numerical I am going to do. You may find out many of these solutions elsewhere, but I am going to tell you how to do it and how to easily do it. So let's start with the first question. So let me dictate the question very quickly, write it down, and then we will solve it. So what is the force between two small charged spheres? What is the force between two small charged spheres having charges 2 into 10 power minus 7 coulomb? 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7. 3 into 10 power minus 7 placed 30 centimeter apart in air. Understand this? Placed 30 centimeter apart and in air. So, if we want to do this problem, mainly what we need to understand is what are these data that they have given, what equation we have to solve, what values we have to write. So, these things we have to understand. Okay. So, now they have given you, first of all, imagine in the physics when you are solving a problem, you need to imagine the problem. So, imagine means visualize. So, what we are going to visualize? Learn to write always one small diagram that will help imagining the problem. The diagram here is there are two small spheres. So, understand that they are small spheres, not big ones. Okay, two small spheres. Why they are saying small sphere? Is because the distance between them is to take 30 centimeters from center to center. And generally, whenever they give distance between two, they give from center to center. This is 30. Okay. So, reason they are used word small is because the radius is negligible. They are very small. Very thin, small sphere, negligible radius. We don't have to worry about how far it is from here to here and all that because the radius is negligible. And they have given charges on each one of them. So now we want to just find out the force between them. So we know that these are both positive charges because they have given no negative charges here. Plus both of them are, if nothing is mentioned, that means plus. Two charges are there. We know very well that if you have two charges, then those two charges actually repel. This is also positive and this is also positive. So two positive charges, very small charges, means they will actually repel. Okay. So when they repel, they go in this direction. This also goes. So, but we are not worried about where it goes. Where we are mostly interested in finding out what is the force. So the force basically is calculatable in terms of using Coulomb's law. So Coulomb's law is the main thing that we use to calculate the force. So let's write down what is the Coulomb's law. Coulomb's law is given by the formula F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. So this generally we know these formulas, but we don't know what are the values to be used. So what corresponds to what? Yeah, so that's why we will say that when you write the formula, you see whether those values are all there. In this case, when you write the formula, Q1 and Q2 are basically nothing but the charge. There are two charges. Okay, those two charges values are given. This one is Q1 and this one Q1 and Q2 are there. Now, you see here, what is R? R is the distance between them, distance between their center, and that is also given as 30. R is equal to 30. And why do we care whether it is in air or not? That is because if it is not in air, if it is in some other medium, then we have to use along with epsilon naught, we have to use dielectric constant K. So since they have not asked for that, then we will just use epsilon naught. Epsilon naught is nothing but the permittivity of the free space or air. Permittivity. It has a value of 8.854 to 10 power minus 12. This is its value. Okay. So if we write it now, all of these, we will be able to calculate the force. Now let's also understand one more thing, that whenever we are writing any of this, we have to write them in SI units. SI units means the units, if they are given in some other unit, we need to convert them into SI units. So how do you convert them into SI units? For example, this one is it SI unit, it's already SI unit. This is also question SI unit. But 30 centimeter is not a SI unit. So meter has to be converted. So 30 centimeter when you convert into meter, it will be 0.3 meter. Because 100 centimeters is 1 meter. So 30 by 100 is 0.3. So 0.3 meter. Okay. Now, if I write all these things, I can get the force in terms of Newton. Again. Okay, so we will write the form, we will write the substitute into that formula. So F is equal to 1 by 4 by epsilon naught is 8.85 into 10 power minus 12. We substituted the first part. Q1 is 2 into 10 power minus 7 into Q1 into Q2. Q2 is 3 into 10 power minus divided by R. R is what? 0.3 square. So most children forget to write the square. They just write it as 0.3 and leave it at that. And you will get the wrong answer. So that's why numericals are harder. That is because of that. It contains very simple things that we need to remember. And yes, we are not saying trying to solve a very hard problem. It's a simple problem. So just taking care that we don't make a mistake. Okay. So now you see, suddenly it looks like a very complicated. So many things are there. How do I multiply? Should I use the calculator or not? So many such questions will come into your mind. So what we need to do is, first of all, is there any other technique that we can use here? This 8.852 and all, 854 and all is calculatable, but a bit hard. Okay. There is one more interesting thing that we have, which is basically this whole of 1.1 divided by 4 pi epsilon naught is also called as another constant k. Okay. It is given 9 into 10 power. So this is much more manageable, 9 into 10 power 9, rather than this 1 by 4 pi epsilon. So we can use it. We don't have to sit with this 8.854 and 10 power 9. So they have actually calculated the value 8.854 and 10 power minus 12 into pi into 4, and they have taken the reciprocal and they have got this value. They have already ready-made got that value. So we will simply write in this place, we will write that 9 into 10 power 9, and this one with 2 into 10 power minus 7 and 3 into 10 power minus 7 and divided by 0.3 square. 3 square is 9. 0.3 square is it 0.9? No, it is 0.09. Why is it 0.09? Because 2 digits backside you have to put the decimal point. Okay. These are all the things that you have learned in 5th and 6th standard and conveniently forgotten sometimes. So I will keep on reminding in a very simple way even the silliest things that I've needed to be done. So now this, how do we simplify? We simplify it by basically look at what we do. Okay. I am going to take only wherever there is no 10 power and write 10. Okay. 9 I will write as it is. 3 into 2 I will write 6. 0.09 I will write below as it is. Okay. Now I am going to basically write 10 power 9, 10 power minus 7, 10 power minus 7. All of this I am going to multiply. I am going to use simple indices. Okay. A power x, a power m, and a power n, a power m plus n. Right. Okay. So 10 power 9 minus 7 minus. Now I'm going to basically do here 9 by 0.09. 9 by 0.09 is, if you want to calculate, it's going to be 100. Why is it 100? Because 9 by 0.09, I'm going to shift the points to the right. 1, 9 point. So since I have shifted it by 2 points, I have to add 2. So 900 by 9. 900 by 9 is 100. So I'm going to write 100 there. This is a simple technique. That's all. Okay. We use calculator. And then in 10 power, see this is 14, this is 9. So totally minus 5. 10 power minus 9 minus 7 minus 14 is minus 14 plus 9 is minus 5. So 100 into 10 power minus 5. So 100 into 10 power minus 5 means 100 is simply can be written as 10 power 2 into 10 power minus 5. Again we use our technique of adding this indices. So 10 power 2 minus 5, 10 power minus. This is the final answer. So we did not have to use any calculator. We were able to do it without using the calculator. Okay. So write it as force is equal to 10 power minus 3. Why did we do? Were we able to? What mistakes we could have done? We could have done the mistakes in terms of 0.3 instead of that 30. If we had written, we would have made a mistake. If we had tried to work with 8.85, 10 power minus 12 multiplying it, somewhere we would have made a mistake. So we cleverly took 9 into 10 power 9. So these are the simple things that you can make your numerical easy to do. Please write down this. So I'll basically move this side. Maybe you can take screenshot and then I'll go for the next. Okay. So next one. Let me erase this. This is the first question. We'll go to the second. Second. So second question is, so let me read it. Please take it down. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb. So I am going to write only important point. Electrostatic force on a small sphere of charge 0.4 microcoulomb. The micro I am writing it as like this. Micro means 10 power minus 6. Due to another small sphere of charge minus 0.8 microcoulomb. In air is important. Is 0.2 Newton. 0.2 Newton is the force. So they have given us the force. 0.2 Newton. What is the distance between the two spheres? What is the distance between the two spheres? And they have also asked what is the force on the second sphere due to the first. This is force on the first sphere due to the second. What is the force on the second sphere? Because so you have two spheres. Okay, one sphere. Again, I am going to put a sphere here, small sphere, and there is some distance between them. We don't know what is the distance. We call it as r. They have asked us to find what is r. R is how much? That is the question that we are going to answer. Now, here, since there are two spheres, they have given basically Q1 and Q2 sphere. So they have said that this force, whatever, so now first of all, one of them is a positive, another one is a negative. So positive, negative means they are going to be getting attracted towards each other. Force will be like this. Unlike charges attract, the force will be like that. Now, if you see what is the force, they have also given the force. It is 0.2 Newton. What is this force? That is the question they are asking. So there are two parts to the question. Question part A is finding out this. B is what is the force on the second charge? Force on Q2 is equal to 1. Okay. So again we know that this is based on Coulomb's law. We already know Coulomb's law formula F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now we already have developed some intelligence. It is nothing but 1 by 4 pi epsilon naught. I am going to put it as A into Q1 Q2 by R square, where K is 9 into 10 power 9. So we will not worry about 8.854 at this point, okay, because it is in air. Because it is in air. And Q1 and Q2 they have given this one. So earlier they had given R and asked us to find out, had given Q1, Q2 and R and asked us to find out F. So in the formula you have Q1, Q2 and R and F. Now they have given F Q1, Q2 and asked us to find out R. The same formula, we just solve for R. Okay. Now we are going to substitute it. Okay. F means how much? 0. 0.2. So now I am not going to write 1 by 4 pi epsilon naught. I am going to write K1. K is 9 into 10 power 9. And Q1, Q2 we will write whatever is given. Okay. Now whatever is given is in microcoulombs. Microcoulombs means basically it's not an SI unit. SI unit is coulomb. So I am going to write it as 0.4 into 10 power minus 6 coulomb. This one is minus 0.8 into 10 power minus 6. Okay. So we are going to write here those things. This 0.4 into 10 power minus 6, 0.8 into minus 0.8 into 10 power minus 6. Okay. And now we have given K and Q1 and R square. R square we don't know how much it is. That's what we have to find. Right, R square. Okay. Now once we write R square, we will be basically saying that this R square we want to find out. So R square is equal to, so this 0.2 will come here. Okay. So and we will also make basically some work out here. Okay, 9, I'll keep it as it is. So this is 10 power minus 10 power 9, 10 power minus 10 power 9. So minus 6 plus minus 6 plus 9. Okay. 12 minus 12 plus 9 is minus 3. So I'm going to write it as 10 power minus 3. This and this, all the three multiplied means this is added. Then 0.4 into 0.8 I will. So 0.4 into 0.8 I'm going to write it simply as, let me write it as 0.4 into 0.8 for now. Okay, let us add, multiply it with 8. And negative is there, that will keep it out. Divided by 0. 0.0.2 the 0.4, correct? So we'll write it as 9 0. What is 9 into 2? 18. Or 0.8 into 2, how much it is? 1.6, correct? So I will write it as. So let's see what I am thinking. What parallel I am thinking. I have r square. So I want to get r. So that means I'm going to take square root. So to take square root, how do I group it so that I can remember? I can actually find out the square root easily. That is what I'm going to do. Yes. So now let's see whether I have done it correctly. Point f is 0.2 Newton. I've got it correct, and this is 0.4 in 10 power minus 0.8. Okay. Now 0.4 in 0.4 by 0.8. 0.4 by 0.2 is 2. So that's also correct. Now point 1 point, this is 1.69 into 1.6 into 10 power minus r square. Okay. Now this I'm going to write as, I'm going to write 9 into, look at what I'm doing. Okay. I'm going to I don't write like basically 10 power minus. I want to write 10 power minus 4 or 10 power minus 2. Why? Because if it is 10 power minus 4, its square root is 10 power minus 2. Correct? If it is 10 power minus 2, its square root is 10 power minus 1. Why? Whenever you take a square root, this will become divided by 2. Because a power square root of a is same as a power half. Correct? So that way, square root of x is same as square root of x by like that it becomes half. Okay. So I want to keep basically the value of the 10 power as a even number. So I can do it like this. I can multiply it by 10 for both of them. Multiply and divide by 10. If I multiply and divide by 10, what will happen? Multiply by 10 will go here and become 6. Divided by 10 will go here and become 10 power. Okay. So this is basically multiply by 10. This is divided by 10. Now I got r squared. Now I am going to calculate r. R is equal to square root of. See, I am not actually doing any calculator. I am doing everything without. Why? Because I am just using some clever technique to get the number in a simple way to be able to work. So I know that 9 and 16 are perfect square. So that's why I keep writing them. So now if I do square root of this, then you can take square root of this, square root of this, square root of this, separate. So because there are multiplication, not addition. Square root of 9 is 3, square root of 16 is 4, square root of 10 power minus 4 is nothing but 12 into 10 power minus meter. 12 into 10 power minus meter, or we can call it as 12 centimeters. So this is how you can solve for r. Actually speaking, if you have calculator, from here itself you can do calculation. Using calculator very quickly you can find out. But we have to practice without using the calculator all these. Then only we will be able to do lots of problems in the competitive examination very easy. Okay, because they don't allow calculators in the competitive. So if you once again just follow it up, what we did was we have used the Coulomb's law, and using the Coulomb's law we wrote these things, basically substituted it and calculating the r square. But here we played a little bit of tricks so that You don't have to use calculator. So we used perfect square so that we can take a square root later. Okay, we know there is r square. So that's how you work with it. Now you got the final answer as 12 centimeters. Now the last part, this is A. This is the A. We got it. B is what is force on Q2. So force on Q1 they have given. Q2 will be exactly same. Why it is exactly same? Because of Newton's third law. What is Newton's third law? If one of them is having a force on the other will have the same force, equal and opposite force. One is an action, other is a reaction. Action and reaction are equal and opposite. For every action, there is an equal and opposite. So this is basically 0.2 Newton. This is also 0.2. So that is the basically answer to the second part, 0.2. So that way we solve basically. So, so please, it is not about how fast you will be able to solve. It is about knowing all these aspects of solving. What all things you need. So later when we solve harder problems, you can do things very easily. Know these all the techniques. Okay. Next question. So I'm going to basically move a little bit outside here, and you can take a screenshot. Okay. Let's go to the next one. Every question, basically you can see that I write the diagram, I write the formula, I write what is given, and then do all the SI units, and then the simplification. Okay, and while doing the simplification, use some ideas of how to make the math simply in a simple way. So that's the basic idea for doing numericals. So next question. So this is basically next question. It's basic in the textbook. It is given as sixth question, but let me write it here. The sixth question in your textbook. Maybe depending on the versions, it might have a different number. 4-point charges. 4-point charges. QA, QB, QC, and QD. Each one is QA is 2 microcoulombs. QA is 2 microcoulombs. And then QB is minus 5 microcoulombs. Minus 5 microcoulombs. QC is 2 microcoulombs again. And then QD is minus 5 microcoulombs. 4 charges are there. Okay. Are located at the corners of a square ABCD of side 10 centimeters. So there is a square. Okay. And it is basically ABCD. And this QA, QB, QD, QC, QD are located at the corner. One here, one here, one here, one here. Charges are located there. Okay. And they are asking what is, so the each side of this is 10 centimeters. 10 centimeters. What is the force on a charge of 1 microcoulomb placed at the center of the square? What is the force on the charge? Okay. There is a, you have to put one charge at the center. Center means I am going to join two diagonals here. This is my center. At the center, we are supposed to keep a charge, which is how much? 1 microcoulomb. 1 microcoulomb. What is the force on this? Force on this charge? Let's find out. So how do we find out force on this charge? So we can actually put using basically what Coulomb's law is, and then we have to then add the charge. This is the first time we are going to now add the forces. So how do you add forces? You need to add forces by using vector knowledge. Okay, you have to use vector to add forces because forces are vectors. So we need to understand that forces are vectors. Means they have direction and magnitude. And how do you add vectors? If there are two vectors like this, the other vector when you add it together, you complete the parallelogram and this is the resultant. That's how you add vectors. How do you add scalars? 2 plus 3 is equal to 5. That's how you add scalars. But you cannot, if this is 2 and this is 3, 2 plus 3 if you add, you will not get 5, you will get some other number. Okay, depending on the length of that diagonal. So adding vectors and adding scalars are not the same. So we will have to actually write 2 here, 3 here and write the correct angle, then make a parallelogram and then measure this thing. Or use some formula. A formula also is there. We can write down the formula. However, in this question, it's not going to be that complicated. Okay, it's going to be basically little more simpler than. So let's understand what it is. Okay. So they have said that QA is 2 microcoulombs. That means 2 microcoulombs is kept, and QB is minus 5. Here minus 5 2 microcoulombs is kept here again, 2 microcoulombs, and 5 minus 5 is kept again. Okay. Let us see what are the different forces that act on that. Now, 2 microcoulombs is positive. This 1 microcoulomb also is positive, right? So there are two of them. So hence we are going to this is trying to push this away. Right? Push this away. This is a force because of the A. So I will call this as F force because of A. I'll just give a notation F. Now let us see what will happen to the 5 minus 5 and this is 1 microcoulomb. So they will attract. One is positive and one is negative. So when they attract, this will be pulled towards itself, and since it is 5, the attraction also is bigger than what is 2 is. So it will be little bigger. So this is basically a. Now let's look at basically the third one. This 2 microcoulombs, this is positive, and hence it basically repels in this direction. But its length, will be same as FA. Why it is same as FA? Because this is also due to 2 microcoulombs. This is also due to 2 microcoulombs. If you actually calculate the force, it will be dependent on Q1 Q2 by R square. So Q1 and Q2 both being same here. Q2 is 1 and Q1 is 1. Okay. So these two being same, this length will be same as the other. Okay. Now similarly for this one, it is attractive and the length is longer, but it will be exactly same as this. Now you see there are 4 forces acting at a point here. There are 4 forces. Now we can sit and calculate each one of those forces using Coulomb's law and then add all the forces factorially. Okay. Instead, we can actually use a simple technique and find out how these forces actually add. So if you add opposite forces that are equal, one is pulling this way, another is pulling this way. So net force due to these, okay, net force due to FA and FB is how much? Okay. It is pulling this way and that is pulling this way, they are equal. So net force due to them is basically equal to 0. That means if you are pulling on both sides the same force, net force is 0. Correct? Due to these two. Similarly, net force due to these two also is 0. So net force due to FB and this is FA and FB. Yeah. This one is FB and FD. That also is 0. You need to write this to be able to basically convey what you are saying. Net force due to this one is also 0, net force due to this. So total net force. So net force then is equal to total. So all are getting cancelled. This is cancelled with this is cancelled with this. So there is no net. So net force acting on one microcoulomb is 0. That's all. You don't have to do much of calculation at all. Remember that when you are actually trying to do actual vector addition and all, you may have to use all this. But in this problem, common sense prevails. Just by common sense, you can answer. You are pulling something on both directions. They are equal. The resultant is okay. So I'm going to basically now go to the next problem. Next problem. Next problem, we are going to start basically getting into electric field. Okay. 2-point charges QA and QB. Okay. 3 microcoulomb and minus 3 coulomb. I'll write it as 2-point charge. So one is QA, another is so QA is 3 microcoulomb, QB is minus 3 microcoulomb. 3 microcoulomb minus 3 are located 20 centimeter apart in vacuum. They are located at 20 centimeter apart. R is equal to 20 centimeter. And in vacuum, this is very important. Whenever they give vacuum or air, we need to know that this is basically epsilon naught has to be used. Correct? VACUUM in vacuum. Okay. So now question basically is, once that is given, what is the electric field at the midpoint O of the line AB joining the two charges? So now what they are asking is there are two charges. Charge 1, charge okay. 2A, so this is A, that's separated by basically a distance which is 20 centimeters. Now they are asking what is the electric field at the midpoint O. So there is a midpoint, call this O. And what is the electric field? Electric field at the midpoint. Okay. And they are also asking if negative test charge of magnitude 1.5 into 10 power minus 9 coulomb is placed at this point, what is the force experienced by the test charge? Now there are two questions. First question is at midpoint E is equal to what? Electric field. Second part is if a charge of how much? 1.5 into 10 power minus 9. 1.5 into 10 power minus 9, that's a negative coulomb. If it is kept, charge of this much is placed at O, then force is how much? How much is the force on it? That's the next question. Now, if you think about it, we have to now start understanding the definition of electric field. We talked about what is electric field. So, electric field is nothing but the force per unit charge. So, electric field is given by force divided by charge. Okay. So, what is the force? What is the charge? Correct. So, now the thing is force at this point divided by the charge that is kept at this point. That's what we have to calculate. Now, however, there is a for point charges, there is electric field formula already. So, point charges basically electric field for point charges. For point charges, electric field is equal to K into Q by R square or 1 by 4 pi epsilon naught, that is K. Okay. We have now realized that we can use K instead of 1 by 4 pi into Q divided by this Q and this Q are not same. Don't get confused. This Q is the Q that causes the electron. This Q is the Q that is placed here. So they are two different Qs. And we always, I have seen children getting totally confused with this Q. Okay. Electric field is caused by one of the Qs. And force is caused because something is kept at that point. So those are two different formula just says Qs, but when you are writing here, you have to be careful. So let us say at this point, so what are the values of Q? So 2A is 3. So 3 micro, this is 3 micro. Yeah, and this side is minus 3 micro. That means if you put 3 microcoulomb here, the electric field due to that, I will call this as EA. It's a vector, correct? EA is a vector. The electric field is a vector. So how to find out what is electric field? You put a unit positive charge and see in which direction it moves. That is the direction. Okay, if I put a unit positive charge, it gets repelled. So arrow should come on that. Its value is given by EA is equal to K into 2A by the distance. Distance is how much? From here to here 20 centimeters. From here to here is 10 centimeters. So 10 centimeters means 0.1 meter square. Correct? This is EA. And it is in the direction that is shown in the diagram. So I am going to write it here as 9 into 10 power 9 into 2A is how much? 3 into 10 power minus 6 microcoulomb. 6 micro means minus divided by 0.01. 0.1 square. This is EA. Okay, I am going to write also EB. EB means electric field due to B. So when you write electric field due to B, now the thing is this is due to B. In B, what is there? Minus 3 microcoulomb. If there is a minus 3 microcoulomb here, the field here is defined by, if I put a unit positive charge, where does it go? If I put a unit positive charge here, because of this it moves towards this, because it's a attract, unlike charges attract. So it moves this way. So that also is in this direction. So I am going to write here this one as EB. EB also is in the left to right direction. Okay. So we will write what is the value of EB. So EB also will be K into QB divided by 0.1. Same, because it is exactly equal. So this is 9 into 10 power minus 9 into 3 into 10 power minus 6 by 0.01. Only thing is there is a negative. Charge negative. So just negative only says that it is basically whatever the direction of the R from here to here, it is opposite. So we are not going to write it negative. Okay, this don't get confused. So whenever we write negative or positive, it is with respect to the distance that you measure from the original source. Okay. Since you are measuring from this side, negative is this. Okay. Now in our case, since we have two scenarios, both of them are in the same direction, we shall not write negative. Get confused. We will take our convention is such that left to right is positive and hence just write the value. So we will keep track of the direction by writing the arrow, and will keep track of the magnitudes only. So, this is the magnitude. Okay. Now, if you find out, if you want to basically get the total electric field there, you have to add the electric. How do you add the electric field? Electric field can be added as not a scalar but a vector. So, vector addition is when they are aligned in the same direction, you can add almost like a scalar. So, you can just simply add. They are in the same direction. If they are in different direction, you have to construct a parallel. Now, total E is equal to EA plus E, which is nothing but this. Okay. I am going to add this. So, I am going, when you are adding these two, these are being same, this 2 into one of them. Okay. I will write it as 2 into. So, 9 into 3, 9 into 10 power minus 6, 10, 10 to the power of 9, 10 to the power of minus 6, 10 to the power of 10 divided by 0.0. Okay. So, you can actually calculate the value of this very easily because 9 twos are 18, 18 threes are how much? 54, okay. 54 into 10 power 3 divided by 10 power minus. So, 3 minus minus 5, 10 power 5. E is this much. Okay. What is the unit of newtons per coulomb? So, its value is very high because we are calculating for 1 coulomb. It's a big number. Okay. So, newtons per coulomb is like E. Now, this is the first part. First part is what? At midpoint, what is the value? We calculate. How did we calculate? We calculate at the midpoint what is the value of E because of A and because of B. And they happen to be in same direction, so we added. When we added them, they became 2E. Then we did little bit of mathematical arithmetic and got the answer. Okay. Now, what if we place minus 1.5 into 10 power minus 9 coulomb at the middle? Okay, when you place them, so you can write here E is equal to 54 in 10 power minus 5 coulomb towards, we have to write both generally. Okay, we have to always write both magnitude and direction towards B. This is the answer. The answer has to be complete. We are writing 54 in 10 power minus towards B. So that means direction of gravity. Now when you put negative here, what will happen? Negative does not move in the direction of B. Negative moves in the opposite direction. Okay. So negative if you put force at O. The force is how much? Force is, you can see here E is equal to F by Q. Means force is equal to E into Q. To multiply Q. This is now we are using the new Q. This Q is kept here. We are not using these two Q's. These two Q's we have already used and calculated E. Now once you know the E, to be able to calculate the force, we used to have to use the Q that is kept. So that is basically nothing but E into E is 54 into 10 power 5 into Q is 1.5 into 10 power minus 9. Okay. So if you multiply these two, 54 into 1.5, multiply those two, 54 into 1.5, 0, 15 4 is 60, 0, 6, 15 5 is 75, 75 plus 6 is 81. 81.0. Is it correct? I don't think it's correct. So 54 into 1.5. How do you calculate? You can use calculator or you make 54 divided by 2. Correct. 54 divided by 2 is 27. Okay, 27 plus 54 is so into 81.0 into 10.10 to the power of this is 5, this is minus 9. Minus. Okay. Towards what? Towards A. This time it is towards A because it is negative. The negative always moves in the direction of the opposite direction of the electron. Positive moves always in the direction of negative. Negative moves in the opposite direction of the electron. So we get the towards A, that is the force. So we calculated this one out. So that's a quick recap of trying to see what we do. We have been given a question where there are two charges that are kept here. In the middle point, what is the electron? We think when if you had basically both of them positive charges of equal value, like 3 microcoulomb and 3 microcoulomb, both of them would have pushed it, repelled it, and they would have cancelled and got 0. Now, since we have got one positive and negative, okay, those being magnitude wise equal, both of them are pulling in the same direction and then they get added. So 2 into that value. Now that electric field that we have calculated into the charge that is kept on, that will give the force. So you have to understand that this negative, positive and all has to be properly used. Otherwise we are going to get the wrong understanding. Yeah, whenever I use negative, positive, I also use the direct so that you will not get a confusion. Okay. I hope you understood that. And with this, I am going to basically close today. We have done at least some 4 problems. I hope you have kind of understood how to do it. In the next week, I'll do some problems from the next chapter, basically capacitors, electric potential. Thank you.